Hey you guys, this is Mr. Sal. We're going to look at some radical expressions or roots and functions and some solutions for those. So thanks for watching. Don't forget to like, comment, and subscribe. So radicals and radical expressions really just deal with roots. Now, to start us out, we're going to be looking at just square roots, which look like this. It kind of has a mystery, I guess. I think it's called the radicand 2 right there. All it's saying for square roots, right, is if they gave you the area, could you find the side length? So if I said the area was 100 square feet, could you find the side length of a square? Yeah, sure you could, right? So you know that 10 times 10 is 100. But there's that symbol for it, and that's the square root business. Sometimes you'll see that called a radical, and that's good too. So this is the radical square root 100, which would be 10. Okay. The square root of a value is the principal value, and we're looking at equations. That's going to change a little bit because it's not always just the positive value. Yeah, there are some situations where I guess the positive and negative would work. We've seen situations like that before with the absolute value stuff, so hopefully it won't be too surprising or alarming. All right, so the square root, the number m is the square root of n if m squared is n. That sounds really weird. It's just kind of backwards. So in other words, the square root of 100, which we saw, was 10, right? That means that 10 squared needs to equal 100. And it does. That's all that's saying, really. But every positive number has two square roots, as it turns out. And again, we'll talk about that. We just don't usually think of the negative values of these because we're usually talking about some kind of measurement. And we don't think about measurements in terms of negatives. All right, so the square root of 121, again, we're just asking if you had the area of a square that was 121, what would the side length be? 11. Done. By the way, there is a square root button on pretty much every calculator. For some of you, at least if it's a TI, you're going to have to be pushing the second, which is the top left button. And then usually it's the x squared button. And then in this case, right, you type in 121. Those are separate buttons. Then you push equals. All right, the square root of they didn't put the first zero there, right? 0.009. So go ahead and type this one into your calculator and just see what you get. Yeah, it looks like garbage, right? At least on your calculators. Even in general, it just looks like garbage. There's no pattern in the numbers. It's just really freaky looking. As far as I remember on the homework, they just wanted you to identify it as an irrational number. That's it for now. Now, in the future, we'll simplify these, but it looks like right now it doesn't really care if we do that. All right, find this square root. Now, again, we could use the calculator, and you guys are good at that now. However, I'm going to show you guys a different way to look at this because it's good for us. The square root of 0.64 is really square root of 64 hundredths. We're just looking at the place value of that 4 right there, right? And as it turns out, when we have square roots of fractions, we can split it up. Square root of 64 divided by the square root of 100. And 64 and 100 are both perfect squares. Again, it's a square thing, right? If I gave you the area of a square with the area of 64, then the side length would be 8. And we've already seen the square root of 100 is 10. And yeah, that simplifies into 4/5. So your decimal would have been 0.8 as 8/10. All right, so that brings up the square roots of fractions, which we just saw. Just break it up into two separate square roots, all right? One for the numerator and one for the denominator separately. Okay, so on these ones, I'm going to break this up write your answers as reduced fractions, okay? So we're not looking for the decimal here, even though we could find it. So I'm going to break this first one up into square root of 1 over the square root of 16. Both of these are perfect squares. The square root of 1 is 1, and the square root of 16 is 4, 1/4, done. Well, what does that mean for this next one? It's just got a negative in front. So, I mean, if we broke it up, it's the negative square root of 1 over the square root of 16, which is the square root of 1 over 4. I'm sorry, the negative 1 over 4. So the negative in front there just makes the whole value negative. That's it. All right, why don't you guys take a moment and try this one. Simplify. We'll make this one a fraction, right? Now, yeah, actually, some of your calculators would just give this to you as a fraction anyways. But let's break it up. Square root of 49 over the square root of 4. Square root of 49 is 7. Square root of 4 is 2. Done. Yeah, if you want the mixed number, then that's fine, but I'm not going to. We have seen this already, the domain of root functions, right? The square root of anything, whatever is inside the square root, I have it in parentheses here, that always has to be greater than or equal to 0. And again, we can look back, for example, the square root of -4, question mark, right? What two numbers multiply together that are the same to give us -4? It just doesn't exist as far as we know right now in this class. Eventually we will have an answer for that, but right now we don't. For this following function, t of x, find each of the following function values. Select the correct option. Put the values in the domain, then compute the function value. All right, t of 1, that would be the square root of 1 minus 5. Oh, we just saw that. Square root of -4. That's not a real number, so can't do that one. What about t of 3? And yes, I did skip that on purpose. The square root of 3 minus 5 is the square root of -2. Again, that's not real either. So what about t of 8? Oh, okay, let's try that one. 8 minus 5, that's the square root of 3. Okay, that's good. Can't really simplify that right now. I mean, we could turn it into a decimal, but it's an irrational number because 3 is not a perfect square. Finally, t of x plus h. We do need to see that one. So, remember, anything inside that parentheses with the t is what we're replacing x with. So instead of x, now I've got x plus h. And then we're going to subtract 5. That kind of goes back to function notation stuff and function operations. Kind of. And if we simplified that, we'd get the square root of x plus h minus 5, because there's nothing to combine with, no like terms to combine with. So that's it. Find the domain in interval notation, our favorite. And as an inequality, also our favorite. That's nice. The 15 there in the front is not going to matter at all. All we're concerned about with is what's inside the radical here, negative 17x minus 10. And we know it has to be greater than or equal to 0. So this is just like solving any other inequality. Add 10 to both sides. Divide both sides by negative 17, which is going to flip that fraction, right? Or the inequality. There's the inequality, which is pretty nice. And on the number line, if we needed it, maybe, maybe not, whatever. Add negative 10/17. We got a closed circle, and that's not eating x, so it goes to the left, which indicates that the interval goes from negative infinity, stops at negative 10/17. Closed circle, so it's included. And there's our two-part answer. Two answers, whatever. Find the domain in interval notation. Okay. Still, we're not so concerned with that square root as much as what's inside it. So, once again, negative 3 plus 9x. This needs to be greater than or equal to 0. I'll need to add 3 to both sides. Divide both sides by 9. And x is greater than or equal to 1/3. There's our inequality. But once again, if we looked at the number line at 1/3, that would be a closed circle. It is eating the x, so it goes to the right. So our interval starting at 1/3, this would go to infinity. Now again, the domain is just to help us understand that the values in that range or in that interval or that satisfy that inequality would give us any non-imaginary number, something real, okay, even if it is irrational. Right, the domain of the function in interval notation. The function f of x equals the square root of x minus 5. So x minus 5 has to be greater than or equal to 0. Add 5 to both sides, and x must be greater than or equal to 5. Didn't want the inequality though. So, as long as x is greater than or equal to 5, we're good. Not that everyone needs it, but again, with the number line, this one's eating x, so it goes to the right. Interval from 5 to infinity. And we can see all the values in the table work, right? They will make the answer some kind of real value, even if it is irrational. So for 20, this is going to be the square root of 20 minus 5, which is the square root of 15. I'm just going to leave it at that, right there. And then 17, square root of 17 minus 5, which is the square root of 12. That can be simplified, but as far as I know, we're not concerned with that right now. Square root of 19 minus 5 is the square root of 14. And then finally the square root of 12 minus 5, which is the square root of 7. Done. When values are multiplied in a square root, take the square root of the values multiplied individually. So like this one, the square root of 81 x squared, we can split that up just like we did with the exponent rules and the fraction stuff. I guess even with the multiplication, whatever. So this is really just the square root of 81 times the square root of x squared, and the square root of 81 is 9, the square root of x squared is x. So that's how we get that 9x right there, okay? And expect to see some of this on the homework too. Finding a cube root is the same as, we talked about that already. Cube roots, oh, this is cube roots, I'm sorry. This is the edge length of a cube from its volume. Okay, so we're looking at perfect cubes, which we've talked about before, right? Like 1 cubed is 1, 2 cubed is 8. When we were looking at the difference of cubes and the sum of cubes, right? 3 cubed is 27. If you can memorize these, not that you really need to, but if you can memorize them, then it's a little bit easier to see values that we're going to be using often, just like we did with the sum and difference of cubes, all right? Again, cube roots can be negative because any number multiplied by itself an odd number of times, if it's negative, would give us a negative value. All right, so 6 times the cube root of negative 64. Oh, sorry. Cube roots on calculators. For those of you with something like a TI-30, you're going to have to tell the calculator you want the cube roots, so you're going to push 3 first. Then you're looking for the second button, which is that top left. It's usually an off-color button. And then you're looking for this button right here. It's called a caret. That's for the exponents, right? Roots are exponents. They're just, we're not looking at them as exponents yet. That should tell the calculator that you want the cube root of whatever, right? In fact, on your calculator you should see 3 and then something like that. Maybe even a parentheses. Well, then you just push the negative button, which is next to the decimal or 0 button, and then you type in 64, and then you push equals, right? If you did just that, then it would give you 4, a negative 4 in this case, right? So this is really 6 times negative 4, run out of space, which is negative 24. Evaluate this. F of x equals 9 cube root of x when x is 1/8. All right, so we're just replacing x with 1/8, right? So 9 times the cube root of 1/8. Again, with radicals, we can split this up so that it's really the cube root of 1 divided by the cube root of 8. Both of which, like we just barely saw, are perfect squares, cubes in this case. So this really ends up being 9 times 1 over 2. And if we make that a fraction for fraction multiplication, just say it's 9/2. Done.